Lesson 21, Mean Absolute Deviations. Alright, so the first thing that we want to do is figure out, well, what is the mean of this data set? And when you're asked to find the mean is another way of saying average. So remember that anytime you see the word mean, you're asked to find the average. Okay, and to find the average of any set of data, you want to take all the numbers you're given, add all of them together, and then divide it by the number of data figures that you have. So like here I would have 1, 2, 3, 4, 5, 6, 7 numbers I'd be adding together. So once I added all these up, I'm going to divide them by 7. So what that would look like is this. Now, when you are doing anything like this, I would recommend that you use a calculator because, because that is just going to make this process much faster. You can do this by hand if you would like, but I'm going to be using a calculator. So here is my calculator, and I'm going to add everything up and then divide it by 7. So let's do 22 plus 26 plus 28 plus 35 plus 45 plus 63 and plus 91. So I get 310, and let's divide that by 7. So this means that the mean for this set of data is going to be 44.28. And let's round that to 44.3. Let's do one decimal place. So the mean for this set of data is 44.3. Now, what this lesson is about, it's about finding mean absolute deviation, or we abbreviate it as MAD. So mean absolute deviation is essentially an average of an average. So to find a mean absolute deviation of any set of data, the first thing you need to do, so to find MAD, or the mean absolute deviation, the first thing you want to do is find the average. Okay, so the first thing you want to do is find your average or your mean of your data that you're given. Then you're going to determine how far each number is from your average. And I will show you what that looks like in a second. Then the third thing you're going to do is take your numbers from number 2, let me write it this way, and find your average with them. That's not how you spell average. Okay, so let me use a different color so that way we don't get anything messed up. Now, this set of data here, we already found the average in. So our step 1 here, we've already done. That average is 44.3. So the average is 44.3. Now, for the second one, this is what you are looking for when you're doing mean absolute deviation. So what I need to figure out is, well, if I'll start with my first number, 22, how far away is 22 from 44.3? And what you can do to figure that out is just subtract them. Now, you can subtract your average from every single number, but always remember to subtract your bigger number first. We don't want any negatives. So I would do 44.3 minus 22, 44.3 minus 26, 44.3 minus 35, 45 minus 44.3. Remember, bigger numbers should always come first because we don't want to have any negatives. Okay, so what I'm going to do for these is I am just going to type these into that calculator to kind of help speed this process up a bit. Okay. So these are how far apart each one of those data points is from our average. So I'm just going to copy these down here. So this is 22.3, 8.3. Oh, whoops, nope, that one is wrong because I typed that number in. Double check your numbers, make sure you don't make a mistake. This should be 18. Whoops, 18. This should be 9.3, 0.7, 18.7, and 46.7. Okay, so now what we need to do is step 3 is telling us to take all of these numbers that we got. So that's all the numbers in this last column over here. We're going to find the average of those. So remember to find our average. Did I miss a number? I did, didn't I? I missed 28. Sorry, let me find 28 really quick. Because I should have 7 numbers. Notice how I only have 6 here, but I have 7 up here. So I have 44.3 minus 28, which should give me 20, but let me just double check. Oh, whoops, nope, wrong way. It should be 16. Okay, so for number 3, we're going to add up all of these numbers together and then divide it by 7. Okay, so this is the second time we're finding our average. So with mean absolute deviation, remember you're finding your average first. You're subtracting all of your numbers from your average. That's what we're doing here. Then you will take your new numbers, which are all of these, and then you're going to use these to find your average. This step right here is you finding your mean absolute deviation. So let's do that with our calculator. And when you guys are doing this, it's very, very important that when you are typing stuff into your calculator to make sure that you aren't missing any numbers or accidentally typing any numbers in wrong. Okay, because this is where if you accidentally put a 6 or forget a 1, it's going to change your answer a lot. Okay, so when I added all my numbers together, I got this 132.3. Then I divided it by 7 because that was how many numbers I added together and got 18.9, which means that our mean absolute deviation for this problem is going to be 18.9. So that is our mean absolute deviation. All right, our next question here is multiple choice. We're given 2 sets of data and we want to know which of these statements best compares the data sets. So if I read through these answer choices first, it's telling me to kind of compare the means and also compare the mean absolute deviations of both of these. So let's start just by finding the mean because that's a bit easier, right? We can do that a little bit quicker. So for data set A and for data set B, let's find our averages. So remember, to find an average, you add up all the numbers you're given and divide it by however many you have. Notice how data set A is the same numbers that we were just dealing with. That average was 44.3. Okay, if I look at these numbers here, they're exactly the same from these ones and these ones. So we've already figured out our mean or our average. So this is our mean. That's what these are. And so let's figure out what the average would be for data set B. Bring back my calculator. So 30 plus 32 plus 41 plus 42 plus 51 plus 59 plus 61. So I have 316 divided by 7, right, because that is how many numbers that we are adding together, which means that my average for this is going to be 40, what was it? I already forgot. 45.1. Okay, so these averages are pretty close together, right? They're less than 1 apart. So let's read through these 2 options that are talking about the means and see if either of them makes sense. Option A says that the mean of the data sets are about the same, but the values in B are more varied than those in A. Well, So they are about the same, but here it says the values in dataset B are more varied. That means that there's more of a difference or more of a fluctuation in our numbers. And if I look here, these are all fairly close together. I don't see any huge gaps in between any of the numbers. So I don't think it's A. Let's read C. C also is talking about means. C says that the means of the data are about the same, but the values in data set A are more varied than B. Well, if I look at data set A, my starting number is 22 and my ending number is 91. That's a pretty big gap, right? And even here, there's no 50s and there's no numbers with 40s or 70s or 80s. So I would definitely say that data set A is more varied than data set B. So on this problem, we actually didn't need to find our mean absolute deviations because I could tell the correct answer was C just based off of finding our averages or the means. All right, here we have two sets of data and it gives us our mean and our mean absolute deviations already. Perfect. We want to know which statements best compare the two classes. Okay, so A says that the average score for class B is higher than the average score for class A. Well, remember that mean is your average, okay? So my mean is my average, and 82 is definitely higher than 71, so this one works because 82 is bigger than 71. B says that the scores for class A are more varied than the scores for class B. Well, I mean, let's think about it. So remember that your mean absolute deviation is telling you how far apart each of the numbers are from your average. Okay, so the larger your mean absolute deviation, the more further apart your numbers are. Because remember that we are subtracting all of these, right? So if we have a wider set of numbers like we do here, our average is going to, or our mean absolute deviation will be bigger. But if these numbers were much closer together, then our mean absolute deviation is going to be much smaller. So with that in mind, this class B has a much larger mean absolute deviation. So since class B has a larger mean absolute deviation, that means that class B actually has a more varied amount of numbers. So class B is more varied than class A in terms of scores, because that's what this question is talking about. All right, so here we have a data set that includes monthly water bills for random cities. Okay, and we want to, it tells us that the mean for city A is 60.8 and the mean for city B is 68.9. The mean absolute deviation for each city is 3.7. Which statement best describes the difference in means in terms of mean absolute deviations? So with this question here, I'm going to draw a number line. I think it's best to visually see this. However, before I start, I am going to kind of round these city numbers a bit. Okay, so if I have city A, 60.8 is very close to 61. For city B, 68.9 is very close to 69. And then the mean absolute deviation, I'm going to take this and round it up to 4. Okay, and I'm going to do this just because it's an estimate and it makes it a little bit easier to work with when we have whole numbers. So now let's draw my number line. Here is 61 and then I have 69 all the way over here. For mean absolute deviations, I can only go 4 units. Okay, because my mean absolute deviation is 4. Okay, so if I can only go 4 units, if I start at 61 and I go 1, 2, 3, 4, okay, this is 1 mean absolute deviation because that is my 4 units that I can travel. However, I'm still not at this 69 yet, right? When I travel up 4, I would be at 65. So let's go up 4 more. So 1, 2, 3, 4. When I travel another 4, that's another 1 mean absolute deviation. And if I have 65, if I were to add 4 to that, I would end at the 69. So it took me 2 mean absolute deviations to get from the mean of city 1 to the mean of city 2, which means that the difference between these two cities is about 2 mean absolute deviations. Alrighty. Next question. So here we have two teams, and the following numbers we're given is about their heights. And we want to know what statement best explains the difference in the medians in terms of the inner quartile range. So IQR stands for inner quartile range. It tells us that the median is middle, which means if I were to go like this and cross off 1 from each side, I would be finding the median. Okay, and you just want to do this until you get to the very center and you can't do it anymore, which means that for team A, 68 would be my median, which is what it tells us down here. Alrighty. And then it says the median for team B is 70. So this is the median for team A and this is the median for team B. It says that the inner quartile range for team A is 4 and the inner quartile range for team B is 3. Which statement best describes the difference of the medians in terms of the inner quartile range? So a lot of you might be thinking, well, if team A is 4 and team B is 3, I would just subtract them to get 1. You are very close. That is the first step. However, keep in mind that these are two different medians. So when we have that 1, which is the difference between the two, we need to divide it by 2, since we are taking into account two different inner quartile ranges. And 1/2, if I were to change it to a decimal, would be 0.5. So B would be correct here. The medians are separated by about 0.5 inner quartile ranges. So that was a lot of new information. If you would like some extra help or want to work through and just see some more examples using mean absolute deviation, please let me know. I would be happy to help. Other than that, have a wonderful rest of your day.